Thank you very much, and thank you for having me. I'll start off with a little video to set the scene.
Yeah, the beat go. Oh, can you believe it? Es perfecto. We can sing us.
This is absolutely incredible.
Try it now.
Right, so as you probably all know, generative media models are getting better and better and better every day. And so with the rise of use cases for generative media, especially in creative industries, there is a parallel need and question of how can we better identify AI-generated content. And so for that, a couple of years ago already, we started researching and investing in a new technology for digital watermarking, specifically for generative media outputs. But let me take a step back first and sort of take a look first at sort of what existed before SynthID. So we took a look at the landscape, and what was really out there was either you have watermarks that are visible but discrete, sort of tucked down in a corner, like it's in this example here, which are relatively easy to crop out, don't really serve a purpose for robustly watermarking content. Equally, if you have more highly visible watermarks, they can be quite intrusive for the visual appeal of the content, and so they don't really provide a viable solution either. And so looking at this, Google DeepMind decided to come up with a new approach, which we call SynthID, and we announced a couple of years ago. And it's really a dual-purpose tool in a way. You want it to both be able to effectively watermark AI-generated content, but then at the second step also be able to reliably identify and detect such content. Obviously, we're starting with Google's own models, and so all our Gen Media models are using SynthID, and the outputs are all watermarked. Let me just briefly run you through how it works. So SynthID works across modalities, so both image, audio, video, and text. At the moment a specific piece of content is generated, an imperceptible watermark is inserted onto the content before the user sees it, and so the two cannot be separated anymore afterwards. The second part of the system, like I mentioned, there is a second model which is trained on detecting the watermark, and it's also robust to various modifications that you could do to a piece of content. And I'll show you a couple of examples on that later. I'll run you through how each modality works, because each one works a little bit differently. For image watermarking, as I mentioned, you start with a generated image from a user prompt. At the same time as the image gets generated, we create a corresponding watermark. So each watermark is individually generated for this specific image. So it's not like a static watermark that looks the same and gets applied to every single image. Once that gets imprinted, so they get, the watermark gets inserted into the pixels in the image, and then this is the output that the user sees, which is the fully watermarked image. And you cannot visibly tell that there has been a watermark applied to it, really to preserve the visual appeal and the visual quality of the image. Audio watermarking works in a similar way. We obviously start with a generated audio track. The similarity comes in as in we transform the audio track into a spectrogram, which you see here. A spectrogram is simply a 2D representation of a song. So basically, you can represent a song as an image, essentially. And the image contains all the information you need to play the song if you want afterwards. And so now that we have an image, we can essentially do the same as we're doing with images. So we again generate and insert a watermark onto the spectrogram. And then we convert it back into an audio track. And now you have an audio track which has been watermarked with an inaudible watermark so that the content doesn't get altered. Video watermarking, you probably can guess it how it works. We basically combine the two approaches. We use the image watermarking for the frames and the audio watermarking for the audio or the music track. Lastly, text watermarking. Text watermarking is a little bit different. So text watermarking, as you probably know, LLMs, they generate text, each token or each word at a time, if we simplify. So one word at a time based on also what came before. And at the moment each token or word gets generated, the LLM faces a choice internally of like, which word do I choose next to like continue my sentence, right? And so at this precise moment, each word, as you see here, gets a probability assigned to it. How probable is it that I will use this word? For this example here on the left, where it says, my favorite tropical fruits are mango, and then you could say plus also and with. And so with this probability, we slightly change the probability. And so this probability then gets changed every time that there is an opportunity to do so. I'm caveating that because in certain cases, like for example, when you're saying the capital of Italy is, then the next token has to be Rome. There is no other option to use anything but Rome. But in lots of cases where you have options and choices, that doesn't meaningfully affect the quality or the meaning of the text, then we can inject these changes in probabilities, which if you do it over a longer piece of text, it results in thousands of these changes. As you see here on the right, this is just a visual example. This then creates a specific pattern that the detector is able to pick up and understand that this piece of text has been watermarked. Now, the drawbacks here obviously are, as I mentioned, we need to prioritize factuality. So if you want the model to generate a specific poem by Shakespeare, we have to generate it word by word the same, so we cannot watermark that. Equally, if the output is very, very short, like what's the capital of Italy, there is not enough information to inject a watermark for it to be reliably detected. But if you have longer pieces of text, which do not only focus on factual events, then the system is very good at reliably detecting the watermark. Obviously, this is also the type of content that for a malicious user is easiest to manipulate and change, right? Anyone can go in and change pieces of text and replace words. And if you do it enough, at some point the watermark will not be detectable any longer. So it's very clear that this type of watermarking is sort of like the weakest in terms of all modalities. This is the slide I was mentioning before on like types of transformations that, for example, image, audio, videos, they are robust to. So if you take the original image on the top, the cute koala, you see on the bottom left the types of transformations you could do that the watermark will persist, right? If you add like filters, emojis on top, you change the color saturation, all of that, the watermark will still be detectable. But then you get to a point, it's always a spectrum. Like if you push it too far, then you won't be able to detect it any longer. Like on the bottom right here, for example, if you like crop out most of the image, there is just not enough information available to reliably detect the watermark. So it's a tricky line. Like when people ask us, oh, is it robust if I do this and that change? Like most of the time the answer is it depends, because it depends how far you push it. Like if you crop out a small corner in the top, it will be fine. But if you remove most of the image or you have an extreme zoom in, then the watermark will not remain detectable. Equally, we do not think of SynthID as like a magical silver bullet to solve all GenAI issues. It's a part of a bigger solution. For example, C2PA is a very good complementary approach to SynthID that works in a different way. I'll show you an example later, but it works with metadata. Metadata gets attached to a piece of content, and it is very good at sort of tracking the provenance of a piece of content and what changes happened to it and how it was captured. But on the downside, metadata can be much easier to remove and strip out from a piece of content, right? And so together, they obviously give you way more information and that you could use to like make a judgment call on where a piece of content came from, has it been generated, manipulated with AI, who captured it. And again, these are not just the only two. There is many more, like you could use fingerprinting, so lots of more approaches to make it more robust. So we always say it's not only SynthID. The more approaches you use, the more robust will be your process of identifying a piece of content. Now I want to show you a detector we built. We launched it a couple of months ago. We specifically designed it for media professionals like yourself, journalists, editors in mind, as a tool to help you identify content you might come across. So let me quickly switch to that here. Okay. Make this bigger. And so it's pretty straightforward. So we started doing it with, we did a couple of user research sessions with in Europe, America, and Asia to test the idea out first and see what's most important to media professionals. And we landed on as easy or straightforward an interface as we can make it. So let me show you a little bit how it works. So for images, let me upload this one. You simply drag and drop it in. The system now runs through it. And then at the bottom, it will give you a result. So this has been now detected as made with Google AI. And you can click on more details here, where it shows you a heat map, which I think is quite cool. So the heat map, now you really see where the system found the watermark. So in this case, the yellow shows you there has been no watermark detected on the surrounding. But in the suspicious camel cheerfully walking on the snow, here, there has been a watermark detected. So it suggests that that part of the image has been altered with an AI tool. Of the borders here in gray, it's not sure because they're sort of like at the border of it, so it doesn't have enough information to make a reliable call whether there has been a watermark or not. So it marks them as like, I'm not sure, which is to be expected in this case. Obviously, you all probably thought about it that this works with Google's AI models. It doesn't work for every model out there. We want this to be as useful a tool as possible, so we have started to propose partnerships with different companies. We've already announced one with NVIDIA. We're actively working to bring more partners on board because the more companies, model providers use it, the more helpful it is for everyone, obviously. Equally, let me show you how it works across other modalities. Let me show you a piece of audio. Let's throw it in here. So now the system scans it. For audio and video, it obviously takes a little bit longer than for images. So it found it's made with Google AI as well. If we click on more details, you see here in blue the parts of the track where it found the watermark. And I want to show you something which is quite interesting. It's a bit of an anecdote. Let me play it first for you, say from here. Oh, nope, not working. Do I need to turn on something? Or? Let me try again. Yeah, sure.
Does it also work with social content? Because that, of course, is more difficult to assess whether it works or not, and rather instead of a source file.
So right now, you would need to get the file and then upload it. We're trying to find a way to how can we make it easier to if you just provide a link and then it gets the content straight from it. But right now, it's not possible to just do it with a link. But if you download the content and then upload it to the tool, then it works. I mean, if it doesn't work, it's not the end of the world. It's fine. Basically, I can describe what's happening. This is a YouTube influencer that is trying a new generative AI tool called DreamTrack, which generates songs. And so the influencer here introduces the song, and then it plays it here. So the song gets reliably detected here, but we were a bit puzzled by this bit here. And then when we re-listened to it a couple of times, we figured out that he was playing the song in the background while he was talking over it. And so the tool was detecting a little bit of the song while he was talking, and then so it was marking it as watermarked. So also, again, shows that the reason why we really want this to be a tool for media professionals is because this does not give you a 100% yes-no answer. You need to interpret the results in the wider context. How has it been created? How has it been shared? Who made it? It's not always a very quick yes-no. And also, if generative AI has been used, it doesn't mean it's automatically fake, because I can have an authentic picture and I change my background color or something. That doesn't mean this never happened, right? I just changed a detail. But obviously, again, if I change the scene completely with generative AI, then it probably has been faked, right? And so it is a technology that requires a lot of context, understanding, judgment, experience to understand what has happened and how this information is being portrayed and presented. So the sort of AI or not tools you see on the internet, they're fun to play with, but from a media landscape, they don't provide you with enough information to really make something of it, really. Let me also show you, for completeness sake, video. Start here, and then for video, upload here. Actually, let me upload this. Video obviously takes the longest, just because you have the image and the audio track to process. This is a combined video from an actual footage and generated footage. And then I want to use this example to also show you some of the C2PA integration with metadata, how that can provide sort of more information on the provenance of this piece as well. There you go. So it detects that there is SynthID. Again, if somebody just takes the signal at face value, they might assume, oh, the whole video is fake. But then if you click, fake, generated with AI in this case, I mean. So if you click here, then you see actually half of the video. So if let's see if I can play it. Oh, it's okay, don't worry. Basically, half of the video is this drone shot, and then the other half, it flips to this, and this has been generated. While you see the whole audio track, there is some background music, all of that was generated, but only half of the video has been generated with AI. Interestingly then, if we upload, if you can go to the C2PA website and upload this video, it will start to tell you, we started with this video as a first ingredient, and it tells you here at the top, drone shot done with Google. So this is the second half of the video that we generated first. And then this is the final video, and it shows you we used Adobe Premiere Pro to make the video. As ingredient files, we used this drone shot here, which is the bottom file. And so it gives you more information on the different components that were used to make this video. But see, this information is not something that SynthID would be able to give you, but because the metadata from C2PA is here, it gives us a lot more information that we can use. So really, again, just to highlight how it is a complementary approach and not meant to be like, this is the one solution you should really use. Let me flip back here. Oh, okay. If you want to use the SynthID detector, you can sign up to it. It's currently on a sort of sign-up list, but we are prioritizing media professionals and journalists for the detector. So you can use the QR code to get to a form. We'll ask you a bunch of questions on like your email address and affiliation, and then you will get access to the tool. And that's pretty much it. Thank you very much. And if you have any questions, I think we still have a couple of minutes.
Yeah, we still have a few minutes for some quick questions. So I think you raised your hand first. So.
Hi, thank you. Very quick question. How robust is this to, I'm assuming the algorithm for generating the watermark is something that is not going to be static. You're going to be evolving that algorithm. So my first question is, does that mean the detector has to keep track of the history of watermarking?
Yes, so we are evolving the watermarking system, which, like correctly you said, we are in parallel evolving the detector as well. So this detector then would upgrade it in the backend to be able to read whatever versions of watermarking that we upgraded to.
The other one is, I mean, an obvious question, but how robust is it to, I'm guessing, jailbreaking the algorithm in the sense of if you had you could design a test image set where you're trying to triangulate towards the watermarking by just having, specifically tweaked images and then use the watermarking algorithm to sort of zoom in on the common.
Yeah, it's a great question, which is exactly also why we are not open sourcing this or making it freely available to anyone, because then we would give malicious actors the tools to basically reverse engineer the solution and, like you said, find a way to extract the watermark and then replicate it afterwards. So exactly that's the reason why. We have open sourced the text watermarking just because we know that it's less robust, and but it can still be very beneficial for model owners. So that is available to any developer on GitHub to download and use. But for image, audio, and video, we purposefully chose to not open source the model to make sure it's protected and reliable.
Thank you. My question is about if you generate a video with audio, video, and subtitles in this sense means like within the video, does this use the two watermarking for video and for visuals and audio, or does it also add the text layer to that?
Yeah, no, good question. In this case, if you have hard-coded subtitles on the image frame, that would be all handled as an image. Text watermarking only works, will only be applied if the output is only text and no other modality.
Right, so last one. For bad actors who, of course, want to use AI to generate different things in this sense, who do not use like the Google AI systems, maybe any alternative, one of the things that we've seen is that there's a lot of revenue that comes from that space, let me put it that way. And if you think about it in a capitalist sense, do you think there's any incentive for other AI companies to join the SynthID system, knowing that that eliminates that portion of their revenue?
Yeah, I can't comment on their approach, unfortunately, but if it's a question for them, right? If they want to prioritize that additional revenue stream and purposefully chose not to watermark their content, then it's sort of their decision. Obviously, we trying to promote the technology and invite more partners to join, but ultimately it's up to their discretion.
Let's take one more question and then we can proceed outside because there are drinks in 13 minutes and I have orders to clear the room. So I think you were in line, yeah?
I don't know if
Yeah. Oh, so sorry. I missed you.
Actually, I was wondering, I understand it. I mean, it would be useful if all the, LLMs or whatever, all the models would put this, because if not, you would need to run an image,
Of course.
different ways.
Yeah.
But also, I'm thinking in reverse, which maybe doesn't apply to you, but I have the feeling that from now on, we will need to mark what is real, not only what is unreal. So are you thinking about developing this in some way that can be applied as a layer to media content so we can prove provenance? I don't know if...
Yeah, it's a great question. To some degree, with C2PA, the metadata-based approach, you can use it in that way because more and more camera makers, they are integrating C2PA. So when you take, I don't remember which ones they are, but you can find out which, I think Nikon or one of quite big ones. So when you, maybe Sony, thank you. So if you take a picture with their cameras, then they add in the metadata that this image was taken with a Sony camera, this particular model. So that gives you that element of like, this is an actual image that was taken with a camera.
And I think we're going to have to wrap up.
Sure.
At this
Amazing.
point. Thank you so
so
much, Armin.
Thank you. Thank you for having me.